Okay, so this is one of those Sudokus that does have unusual rule set. So these are not our regular arrows, but that the digit in the circle is the mean of all the digits along the arrow. So first of all, we can tell that these need to be the same parity because they need to be 0 mod 2. So these are either both odds or both evens along this 2-cell arrow. Is that gonna be helpful? So we know that these, well, we don't know anything about those. We know that these are the same parity, polarity, whatever you want to call it. Okay, so what about this one? So these are 7 cells, and so their sum must be a multiple of 7. So what multiples of 7 are possible with 7 Sudoku digits? So they could be 28 if they were the bare minimum. So 4 is possible. 35 is possible, missing 2 summing up to 10. And 42 is possible, missing a 1 and a 2. Okay. So what else can we learn from this? We cannot put a 1 or a 9 in any of the circles, because obviously if we had a 1 or a 9, the entire arrow would need to be made up of 1s or 9s. So what we can say is that 3 times this digit is equal to these digits. 2 times this digit is equal to this digit. Can I make use of that in some way? Maybe I should just do some quick Sudoku, although there isn't too much to mark here. Okay, so that 1 can't be here. 1 is among these arrows. Doesn't seem all that useful, but might as well put it in there. Okay, so I notice I have a lot of odd digits here. Maybe that has something to do with something. So this 3-cell arrow needs to be 0 mod 3. Okay, does that tell me anything about the number of evens and odds? I don't think so, because it could just be 2, 4, 6. Okay, if these were 2 odd numbers, it's either from 1, 5, and 7, meaning our average. Well, it can't be 1 and 5. 1 and 7 for a 4, 5 and 7 for a 6. If these were 2 even numbers, I'm not sure this is the way to go. I know that this is there's just too many options in here. If it's a 4 or 6, these are extremes. It's either a 1, 2, or an 8, 9. But if it's a 5, there's just way too many options. So there's nothing wrong with a circle digit going on its arrow. We could just easily have something like, oh no, that won't work. Let's do that. So we could easily have something like that. So nothing wrong with that. Has to be a 7 on these arrows. Oh. Okay, so this can't be an 8, because that would require 9, 7. Can't be a 2. Do I really need to... Okay. So if it's a 7, it needs to be 6, 8. So we have 2 times this digit plus 3 times this digit plus 12 plus this digit is 45. So I guess we could look at it as this whole thing is 3 times this digit. Maybe that's what I'm supposed to think? Oh, hold up. No, I got it. So these 3 together are 0 mod 3. This is 0 mod 3. These are 0 mod 3. This number needs to be 0 mod 3. So this is a 6. This is a 6, making this 42. Okay. And same, well, not the same here, but these together are 0 mod 3. This number needs to be 0 mod 3. Okay. Now what? This isn't the 1. This is a 1. 1 goes here. One goes here. Okay, so what? How else can I apply this? I can't really apply this. Well, I guess I could, right? Because these all together are some kind of multiple of 3. I mean, I can narrow down this cell. Because this is 2 mod 3, which means I need a number that's 1 mod 3 in here. Correct? Am I... Is that just a 4? Am I doing that math right? So this is a multiple of 3. The whole thing's a multiple of 3. This is 1 less than the multiple of 3, so I need 1 more. Yeah, I think this is correct. So we have another... So this is 1 more than a multiple of 3. So I need one that's, negative 1 mod 3 or 2 mod 3, same thing. So I need 1 under a multiple of 3. This is on purpose, right? These are both, yeah, this is on purpose. This has been selected very carefully. So where do I go from there? Can I now tell something about... So now this can't be 7 because 7 requires 6, 8. It's not a 6 because there's a 6 right here. So these either add up to 8, which would have to be exactly 1, 7. So that's one possibility, is that they add up to 8, and they can't add up to 8 in any other way. Or they add up to 10, which would have to be 2, 8 is the only way they could add up to 10. Okay. Well, okay, so hold up. So this is either 12 or 15 in total. So we can narrow down this other sum. So if we have 12, 12 plus 18 is 30, leaving 15, putting a 5 here, and in the case, so if this is a 4, this is a 5, and if this is a 5, is this going to need to be a 4? So we have 15 plus, yeah, this would have to be 12 in this case. So these are a 4-5 pair, and let me go ahead and mark these with different colors to remember that. So the blue digit needs to go on its own arrow somewhere. Oh, and it can't go here because there's no, it can go here. Never mind. The blue, I don't know why I said it can't go there. There's a Sudoku, man. Sometimes you get like so caught up in the logic that you forget to look for the numbers looking at the squares you just pencil marked. You know, so this is 2, 8. It's not a 1, not a 7. And oops. And this is 1, 4, 7 to make 12. Yes. 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 Good. Let's pencil mark some stuff. And then hopefully not ignore it later when we need it. 5 in here. Oh, there's a 1 looking right there. Okay, where do we go next? Do I look at this 6 cell? These are 18 in total. So with a 4, we need 14, which could be 6, 8, or 5, 9. There's no 1 or 7 on there. Okay. Not entirely sure where to look for the moment. Oh, there's no 1 here. What are these numbers? We only have 3 numbers left here. We have 5, 7, and 9. This isn't 5. Okay, so this has dragged up this number pretty big. If there's a 1 on here, can't be 1, 3. So it'd have to be either 1, 7 for a 4. Can't be 1, 9. So if it's a 1, it has to be exactly 1, 7 to make 4. Okay. And if it's not a 1, then it has to be what? If it's even numbers, it'd be 4, 6 to make a 5. So it's not even numbers. These are odd numbers on here. These are odd numbers on here. So it means what? 4 is in here. One isn't here. So if this is 4, it needs to be 1, 7 because it's not 3, 5, or 2, 6. What's the other way to use the odd numbers in here? So we have 1, 3, 5, 7, 9. Let me just write them all in here. I can't put a 1 there. So we can't do 7, 9 together. Well, we already knew that because one of them's in here. Can't be 1, 3. Can't be 3, 7. It could be 3, 9 to make a 6. Can't be 3. So 3, 9 is one option. 1, 7 to make 4 is another option. Are those the only two options? Are those the only two options? Well, these are two odd numbers, so this has to be an even number. Right. No, that's not true. Ignore that. It's completely untrue. But I think these are the only two options. Can't do, so 1, 3 doesn't work, 1, 7 yes, 4, 1, 9. 1, 9 doesn't work. So then 3, 7, no, 3, 9 for 6. Then I only have to look at 7, 9 for the last one for 8, and that doesn't work. So we know that this is either 12 or 18. And then we have 15 here. So if you have 15 plus 12 for 27, we're missing 18, which would put us... So is this going to be another 4, 6 pair? No, it can't be. Because, okay, so if this is a 4, this is a 6. And if this is a 6, we have 18 plus 15 is 33. No, wait, it is. It is, isn't it? Right, because this is 3 times, this is 3 times. And yeah. So now this isn't the 4. This is the 4. This is the 6. This has to be 1, 7 to make 8. This is a 9. This is 3, 6. Nice. Okay, that didn't actually resolve much. So we have a 3 in here together with a 2, 8, and then we have a 9 in here together with a 2, 8. Okay. So what's the next thing I can tell? We have a, maybe pencil mark this stuff, a 1 in here. Okay, so what information did that give me? Like I have nothing more about here, but maybe it told me something about this. So we have 3 times this number and we have 3 times this number. Maybe we can tell something about what these numbers add up to. So this is possibly 12, which means we need 33, and these would add up to 11. And then the other option is this is 15. We need 30, so these add up to 10. So these two either add up to 10 or 11. 10 or 11. Okay, maybe something, maybe these are better because these are in line with each other. And we know exactly what this is. So this is 12, meaning we need 33. So these two add up to 11. There's no 4 in either of them. So it's not 4, 7. I don't know. Well, I know I can't put a 9 in either of them either. So we have 3, 8, or 5, 6 are the options. And this can't be an 8 because this would need 7, 9 there. So 3, 8, or, so this can't be a 3 anymore. This is a 5 or 8. 3 needs numbers adding up to 6, which I can't do, right? I can't do 1, 5, I can't do 2, 4. So this is a 6, making this a 5. These are 12. They are not 4, 8, or 5, 7. They have to be 3, 9. 9 and 3. So now these are 2, 8, 5. Okay, which does in fact add up to 15. So that's so far so good. This is a 2, 8 pair, making this 1, 7, 9. We know that there's a 3 in here. We know that there's a 6 in here. We know that there's a 2, 8 in here, and then there's also a 5 in here. So these need to add up to 18, and the biggest they could be is 865. Does that mean it needs to be 864? Yeah, because there's 1 degree of freedom in 865, so it would have to be 864. And then this is the 8, this is 4, 6, so this is a 2, 5, and then, oh, the 8 right here, 2, 8, 5, 2, 2, 8, these are 3 and 5, okay. That helped me narrow these two down. I said these are either 10 or 11. So it's not 3, 7 to make 10 because I can't put a 3 or 7 in here. It's not 1, 9. Did that tell me anything else? It's not 1, 9, so it could be 2, 8 to make 10. Maybe I should pencil mark this. It could be 2, 8 to make 10. It could be 4, 6 to make 10. And then our other options are to make 11, but it can't be 5, 6. It could be 4, 7 to make 10. Oops, I didn't want to undo the 4 there. It could be 4, 7 to make 10. Could be 8, 3 to make 10. Then I'm gonna pare this down. 3, 2, 9. Can't be 2, 9. Yeah, okay. So this is not a 2 or a 6. So 3, 8 is a possibility, 7, 4 is a possibility, 8, 2 is a possibility. But if this is 2, this needs to be 6, and this can't be 6, so this isn't 2, meaning that this isn't 8, which means this does need to add up to 11, so these are 33, meaning that this is 12. Okay. I hope I'm not making some kind of massive blunder here in my math that I'm only going to find out when I reach the end of the puzzle and it doesn't quite work out. I've just been kind of not really double checking anything. So these add up to 11. So if it's a 3, these need to add up to 6, but they could be 2, 4. Have to be 4, 2. I see nothing wrong with this. If it's a 7, we need 14, which would, oh, I can't make 14 in there because I can't make 5, 9, or 6, 8. So this is 3, this is 8, which means that this is 7, 8, 9. This is the 9. That's the 9. These are 7, 8. These are 2, 4. This is a 7, 8. These are 5, 6, 7, 8, which means there's no 1 on here because this is at least 10. Oh, wait, no, almost messed up. That could be a 1 because this could be a 9. Actually, I know exactly what these digits are. 1, 2, 3. And we know that there's a 9 here as well as a 4. Okay, so first of all, this can't be 16. This also can't be 14. So it's either a 5 or a 6. So this is either 10 or 12. So there's no 4 there. This is 7, 8, 9. So we obviously have many different ways of making 10, but only one way of making 12, which is 3, 9. This is a 6, 4, which is resolved. There's a 2 in here. There's a 3 in the whole thing. And, oh, there's a... Jeez. I swear, sometimes you just don't look at the pencil marks. Okay. So this is not 8. This is 7 or 9. Making this not 2? True. Okay. So this is 2, 3, 9, not 2. There's a 6 right here. 4, 6, 4, 7, 9. 4 here. Oh, there's a 6 right here looking straight at him. This is 10. That doesn't help us resolve. 2 there. 3, 1. That does help us resolve. 7, 8, 6. Hopefully on the home stretch of this with just some Sudoku left. This isn't 1R7. We need 3 and 9 in here. This is just a 8. We need a 5 and 7 in here. This is 2, 3, 9. It's not 3. 5, 7. This is 2, 3, 9, but it's only a 3. 3, 3, 9, 2, 9. No. That was just oops. 8. Nice. That was fun. That was something. That was a rule set I hadn't seen before, and it involved a little bit different thinking than I'm used to doing in these Sudokus. So that was a really cool puzzle. Enjoyed it. And ending the stream.